So if the population was 298 million in, 2006, and then it was 323 million in 2016, we're going to subtract those doing 323 minus 298 to get 25. So then we could say there was an increase in the U.S. population of 25 million people from 2006 to 2016. Pretty straightforward, I think, right? And had the number gone down, then we would be using the word decrease. We would have gotten a negative number, and we would have just used, we would not say there's an increase of negative 25. We would say there's a decrease of 25 million. So speaking of decrease, we have Juliet's weight, and it went from 180 pounds to 162 pounds from May to December. So if I subtract those two numbers, what do we find out? 18. So we could say that, and is it positive 18 or negative 18?
Positive. From 180 to 162.
So it would be negative, right? Because the December is the ones, so her weight went down. So when we read it, sometimes you might have said, well, I just said 18, but I would have said she lost 18, right? So I could say Juliet lost 18 pounds from May to December. Or I could say her weight decreased by 18 pounds from May to December. Many ways I could word that. So don't get extremely hung up on like the negative part of, but as long as you are writing the sentence that reflects that that's a negative number, that she lost the 18 pounds. So next we're going to look at the median income. So again, these absolute change, we're just subtracting. Oh, let's go a little bit bigger here. Yeah, we're going to get into some numbers. We will want calculators. No, it's fine. Somehow I end up with about 4 of them on my desk daily, but I still have one here. Thank you for checking though. So the median income in the U.S. was $57,230 in 2015 and $59,039 in 2016. So what is our absolute change? So 1,809.
Increase, right?
Mm-hmm. So I could say the median income in the U.S. increased
or the median income between 2015 and 2016 increased by.
Mm-hmm. Yeah. You could slip the date in the middle, sure. But I need to be showing that it is going up. I need to give the date, give all the information, but it is basically just a subtraction. Now, in this case, we knew that it was increased because 2015, 2016, we know which one is the newer amount because 2016 came after 2015. And the original or the oldest thing is the base or the reference. When we have, there's nothing that's new or old, then we have to compare with the person, like these people in this case, they're going to be with their names. So if we're referencing John, so this will make more sense, especially as we do the ones that are percents. But compare Miguel to John by finding and interpreting the absolute change with John as the reference. So first off, I need to change the 6 foot 2 inches and the 5 foot 9 inches both into inches, or I need to be able to do that subtraction. How many inches difference is there? So I've got a couple ways I can do that. I can change that to 74 minus 69, because there's 12 inches in a foot. Or you can borrow. I don't know if any of you ever thought about this. You can borrow, but for the 1 foot, you don't get 10 inches, you get 12 inches. So this becomes 14 inches minus 9 inches is 5 inches. We still get 5 inches, right? So the difference between the two is 5 inches. And then this is where it comes in, and it's going to be different depending on who we are referencing. So if we were referencing in comparison to John, then we would say Miguel is 5 inches shorter than John. The one that's after the word then that's who we're referencing. That's who we're comparing things to. We are comparing Miguel to John. And then if we want to change it to having Miguel as the reference, then what we're comparing is really that difference compared to Miguel. Now, it's not going to look so much different. It's just going to be different words. So I would say John is 5 inches taller. I can't say shorter anymore, right? Taller than Miguel. So we never really use a -5 because we're just using like shorter and taller.
How did you find the calculation of the 6 foot?
So each foot is equal to 12 inches.
Right.
So if I do 6 times 12 plus...
The second.
Oh, the second way I did it? The way I did it over here? All right, so what I did is I said 6 foot 2 inches, and I want to subtract 5 foot 9 inches. I can't take 9 inches away from 2 inches, right? So just like if I was cutting a board, I wouldn't need to cut every board into a bunch of inches. I would just need to cut one of the boards. When I cut one of these 1 foot boards, now I'm left with 5 full feet, but it gives me 12. And then 12 plus the 2 is 14. And then I can do 9 minus 14. In this case, it may be just as easy just to change them all to inches pretty quickly. But what if it was like 106 feet, 5 inches, and 97 feet, 8 inches? I don't need to make some huge number of inches. I could just borrow 1 foot. But just know when you borrow, you're not getting 10, you're getting 12. And then you add on whatever you already have. Again, the big numbers with a giant number of inches with a calculator is not such a big deal. But I came from the schooling when I was not able to use a calculator. And so knowing how to do it that way kept the numbers much more manageable. So do we get the same value in parts A and B? So we can use 5, but the sign is different. And so that's why we had to use shorter and taller. So then we use different words. So we never really said -5, but we used the word shorter.
So yes.
So, well, do you consider -5 and +5 to be the...
Well, since we're using 5, we're just using different words.
Right.
Same
as long as you know that you have to use the increase or decrease or more or less. So I think they are probably looking for us to say no. Because when I read this, when we make those comparisons, a positive number means the item in question is more than the reference, and a negative tells us it's less than the reference. I think oftentimes we just do the subtraction and we just intuitively know, we can see which one is more or less. But notice we have to pay attention to that. When how this is written, then the reference item, what are we referring to? And when we do the percents, it's not just going to be a sign difference. So relative change is also called percent change. So we have to find the change, find out how much it changed, which is what we just did, and then we divide it by the original, the reference, the old value. So if there's two different times given, it's always the older of the things. If there's not two times, then we have to look at the wording to see which one is the reference. So an example, looking at the U.S. population, when we subtract that, we get the 25 million, right? So the 25 million, or just 25, over 298, because 298 was the older number, we divide it, and then we can move that over to make it a decimal. You can also do 25 over 298, x over 100. Okay, so instead of dividing and then moving the decimal, if you like your percent using the proportion, it's basically just adding that to it to change it to the percent. So number one, we already did the subtraction. We know that her weight went down by 18. And then how much was it originally? 180 pounds. So then when I figure this out, whether I divide and move the decimal or I cross multiply and divide, then we come out with negative 10%. Or the negative is going to be taken care of in my sentence. I could say Juliet's weight decreased by 10%. From what, May to December. May to December. Good job, Juliet, even through the holidays there. She didn't do so much holiday eating, I guess. So notice we had already found the 18. So number two, we're going to use our number. We should use our 1,809. And then on the bottom, are we using, which one is our base number? The 57,000 something or the 59,000 something? So which one of these goes in the denominator?
59?
Which one is the older amount? 57. So when we say that something like increased a certain percent, the percent is based on the old one. So you use the original. It doesn't matter if the original was lower or higher. It's whichever one was the original. So we can cross multiply and divide. We could just divide and move the decimal. But we could say 3.2%, or we could just round that to 3%. I went with 3.2 because they used 8.4 above, so I just went with the same number of places. So the U.S. median income increased by 3.2% from 2015 to 2016. I suppose since that's just 1 year, I could probably just say in 2015, but I'll leave it worded the same way that that was.
So this relative change and absolute change, would you think about it as part to parts and part to whole?
No.
Would you sell this?
When we are finding the absolute change, it is just a number, the difference that it's changed. When we're saying the relative change, now we're saying it as a percent of the original. So if I told you I got $1,000 raise, you know, to me that sounds pretty good. $1,000 per year. To someone else, $1,000 raise would be, that's not even inflation. Well, I guess it's not even inflation maybe for me. But if someone made $200,000, that $1,000 raise, the percent, the relative would be small. So sometimes it's going to give us different kinds of information, right? So just like Dawn mentioned to me today, she was reading something about school board candidates, and one of them had something about, they mentioned English language learners in Noblesville schools. And they threw out the number 600. And at first, she said, I thought, 600, wow, that's a lot. But Noblesville School has over 10,000 students. So suddenly, prospectively, she thought, compared to our school that has over 100 who was not their first language, out of 191 right now, the percentage is very different, very different. So the relative gives you that perspective, right? The absolute is just the number, right? So here's where things get interesting. Is if we are comparing John and Miguel, I don't know their age. We're not saying like who's the oldest. We have to think of it with different people as the reference. So we already found out they're 5 inches of difference. But if I am comparing, and Miguel is actually 5 inches shorter, so I'll go ahead and make that -5. And if I am comparing with John as the reference, I use John's height on the bottom. And I would need the 74 there. So for this, I would need to change it all to inches because I can't really make a meaningful comparison using 6'2". So I came up with, or someone else tell me, what did you come up with? To the nearest 1/10 of a percent, we'll say. How much? Did you do 500 divided by 74? Maybe I didn't.
6.75.
Okay, so I could just say -6.8, -6.75. Maybe I even say that it's about 7%, right? So I would say Miguel is 6.8% shorter than John. When I say then John, that's the clue that John is my reference. So if we use Miguel as a reference, are we going to come out with the same percent?
No.
Why not?
But it's going to be positive.
But will the percent be the same?
Same, yeah. 74, no.
It will not be the same. No, it's not the same And it's not just about the sign. It's not the same due to a change in the base. So if Miguel is the reference, change in the reference or the base. If Miguel is the reference, it's not -5, it's not 5 over 74.
69.
It's 5 over 69, which is not, obviously mathematically cannot give us the same answer as 5 over 74.
Does that say no, it's the same due to the change?
I'm sorry, it's not the same. Thank you.
I was like, you just said the opposite of that.
It's not the same. For anyone who later watches this video, you can thank Chris Jackson for me adding the word not so that you're not perpetually confused. So it's not the same because we're going to change the reference. And then that's what we're asked to do in the next part here. So now we're comparing the difference to Miguel. Or I'm not honestly not sure if they're looking for me to say John to Miguel or the difference to Miguel, but the reason I choose to use the word difference here instead of John is because I don't want you to think you're supposed to do John divided by Miguel, right? So we still have 5. It's not negative now, but we would have taken care of that part. And then I came up with 7.2. So then I would say John is 7.2% taller than Miguel. So interesting thing about this, it kind of feels like we should get the same number, right? But because we're comparing to a different thing, it's not the same. So, and there's a little like brain teaser about this that says, so if your boss told you, hey, things are really rough this year, you know, I need everybody to give a little for the company, and for the next 3 years, I need you all to take a 10% pay cut. But then the next year, I'll give you a 10% raise. Okay? It sounds like, okay, we're going to be back.
I see it.
But when you take the 10% pay cut, for every $100, you're going down to $90. When you get the 10% raise,
90.
you're only going to get $9. So you would perpetually be taking,
And you expect that, that 10% is the same exact value.
but it won't be the same because then they would be,
It's based on that.
exactly, because when we change the base, it changes
Okay, I get it.
that. So
Just want my water.
So if someone says, hey, if you lower that by 10%, then next year we'll raise it by 10%. It doesn't actually,
So as long as the base need to.
the base would have to stay the same. Mm-hmm. Okay, I felt like I needed a ruler when I looked at this. So you may want a piece of paper or something to lay across your thing to get an idea. I probably am, when it says estimate, but like I can't call that bar 116,000 when I see it's above 116,000. I called the bar for 2005 116,500. Because it's not halfway, right? That would be 117,000. So I called it 116,500. Thank you. But like the ones that are further away, the ruler might help. I would not try to get any closer than the 500. So if it asks me the absolute change, absolute just means we're subtracting. So I use the numbers 116,500 for 2005. And then for 2009, I used 109,500. Does that seem accurate? I mean, again, these are not exact, but we'll go to the nearest 500 that we can figure out. So from 2005 to 2009, we can kind of just see by the graph that the median sales price of Indiana homes went down. So we would get a negative number if we take 2009, take away 2005. And again, this one is just absolute.
So you just said $7,000 increase?
Was it a $7,000 increase?
No, decrease.
Decrease. The absolute change, or I could just say the median sale price in Indiana dropped $7,000 from 2005 to 2009. I suppose I should use the word home in there somewhere too. So I subtracted, and then if you're, again, using the time, so really we would be doing this, even though mentally I would do the subtraction in the other order, we're taking the more current, subtract the older one. So that's why it's negative, which we can get then as that it dropped. So then we're going to use negative 7,000. And then what number belongs on the bottom if we are doing the relative change? Which one was first? So again, 2005 to 2009.
2005.
So that was the 116,500. Again, you can divide and move the decimal or use your proportion. Yes, that's what I came up with, 6%. So I would say the median,
Negative.
yes, so I figured you would add that in. So the median home sale price dropped, so I could say it decreased, or I could say it dropped 6% from 2005 to 2009. In Indiana, I suppose, if I'm being really specific. Because that may not have been the case in, say, California, Colorado, places where it was still going up. But they did drop in Indiana over that time period. Okay, so now all in one step, number 3 is asking us to do the same thing, but we're looking at 2009 and 2012. So there's no question that asks you the absolute change, but of course you have to find it because that's the top of your ratio.
You get 118 on that?
No. What did I use?
2012.
What did I use for the?
You use 118.
Well, I was really trying to estimate. So yes, 118. Again, this would be a reason why you would want to always show your work. If someone used 118,500, but I see that their work and it's an estimate, then I'm not going to ding someone because we can't tell exactly on the graph. So what would be a good sentence? And what is our percent here? I'm going to get all this stuff out of the way. I'm going to go ahead and say median home sale price in Indiana. Did it rise or fall over that time period? Increased. By what percent?
$7.76.
So it's 7.8%. So guys, I'm not going to, so if it does not tell you, then 0.1% is typically pretty acceptable. If you did tell me, if Muhammad gave me this answer and told me 7.76%, okay. If someone gave me this answer and told me 8%, okay. It's supposed to be an estimate also, right? It's an estimate. So any of those things would be okay. But if you choose to give me 1 decimal place, 7.7% is not okay. Do you see why? Like if I choose to round it to that place, then it needs to match the numbers that I used, right? Again, it is an estimate, so maybe that's actually closer, but from what we can tell. So we could say it increased by that percent. Or we could just say it increased by approximately 8%.
Yes. Can you say it increased by 8,500?
Not if it's relative change. Okay? So if it's asking for relative change, we have to do the percent. Mm-hmm. Okay?
So you start with finding the absolute change first, right?
Yes.
Okay, so that would be, you have to go in order of the sentence, right? So I would go from 2009's numbers.
So if it is dates, you go from the newest, take away the oldest. The new value, take away the old value.
So that would just leave me with a positive 10,000, right?
Well, it depends on what numbers you're using.
I was just going to use,
So
I guess I was rounding up with 2009's.
So I think what we used was 118,000 and 109,500.
Okay.
Because we had already used 109,500 on the earlier problem.
And it also probably make that logical sense too. If you put 8,500 divided by 118, then it's going to give you a
It would still be an increase, but it would be a smaller increase.
Right?
So, but you're always, it doesn't matter if it's the lower or the higher, you're always using the older a number. So now, I want you guys to just look at, this next one is a look at and think what you, and tell what your perception is. So I'm going to show the graph again, and then read the question. So, according to the Indiana Association of Realtors, at 118,000 last year, well, last year, this was written a few years ago, right? The state's median sales price for existing homes was 4% higher than in 2011. Does the graph look like a 4% increase from 2011 to 2012? So when I look and I compare 2011 and 2012, visually, does this just look like 4% increase?
It doesn't look like it, but it is, right?
I mean, I'm comparing 2000 and if we look at 2009 to 2012, it was 7.8%.
But visually,
Yeah,
This looks like, if this is 100%, this is like 150%. Do you see where I'm
Yeah.
going with that? Visually. Why is that? Why doesn't visually it match up? If we do the math, it does match up. It is 4%. What is it about the way the graph is done? Why does 4% look like it's such a big, because part to whole should be like 4 to 100, and that's that's not,
Because they're doing the same thing with maps, right?
Right, but I mean, like, what's happened on the graph? Why is 4% such a huge proportionally? Any ideas? Where does this
I
start?
was gonna say, does it start from zero?
It doesn't start from 0. So the heights are not proportional to the prices. Because if you see this one and this one is more than twice as high as this one. Do you get what I'm saying?
Yeah.
Like, if I slid this over and doubled it,
Should be two.
so that kind of makes it look like, wow, the prices are like more than double. But they're not more than double because the scale doesn't start at 0. So that's something like when you're given information, yes, you need to look at the actual numbers, but you also need to realize that people create graphs like that to exaggerate a difference, right? So if I make this scale, what if I didn't, nothing's under 108.
Big.
I could make the scale start way up here. And then it would make that look proportionally, wow, look at these big jumps. And yeah, it's a difference, but this big jump
4%.
is only 4%. So sometimes visually, when someone creates a graph, sometimes they want it. I mean, they want it to look like more than it is. And sometimes it's not intentional, but that's what happens, is then visually we just think, wow, man, 2012, man, in 3 years, looks like the price more than doubled. Well, that's not true at all, if I look at the actual numbers.
You do that with maps too, right?
Yeah, the scale of the map, how things are placed, how a globe looks compared to a flat map, the size of things that we get misinterpreted depending on how they are. So, just a little. So I wrote it, no, it looks like a larger percent since the bar is about half a bar, 1.5 times the height of 2011. But when I did the math, I actually came up with 0.044 or 4%. So when I tried it, like what they told me was accurate, but it just doesn't look like that because we're not starting at 0 for our price, which I get because then we'd have these really tall bars. But proportionally, when our axis doesn't start at 0, proportionally things look very different. So, housing and urban development. We're going to find absolute changes and then relative changes. So, you're looking at each city. So, for instance, when it gets down here, we're comparing between the 2 years, and our percents are going to be rounded to the nearest tenth of a percent. So, keep 1 decimal after your percent sign. So, for example, when I did Fort Wayne, why did I just do that? No, I don't know what's going on. When I did Fort Wayne, I subtracted 687, subtract 508. So I took the 2005, subtract the 2000, I get 179. And then to find the relative change, what am I going to divide by?
By the 508.
by the 508, yep. So I did it this way and then just moved the decimal,
35.2.
yep. And then you'll see at the bottom of that page, there's already a sentence written about, which I find kind of amusing because then when they wrote the sentence, they just put 35%. They didn't put 35.2%. But I suppose that's the most meaningful, like, understandable as far as meaningful, easy to understand too. So go ahead and finish that table and then write the sentence about the absolute change and relative change for Indianapolis. So basically finish that 7-4 page, and then we'll do some comparisons between communities instead of between years.
What decimal point do we go to?